Hello everyone. Thank you for being the call. Today we are going to discuss about and see the complete incident response on and the digital forensic and malware analysis on Medusa Ransomware, which was should be world today. So just wanted to provide the in-depth analysis, like how we started on with the IR and how we performed the malware analysis at the back end and identified the real-time IOCs that were identified from the SIM, and we firewall. We immediately blocked those IOCs, but what exactly the IOCs that can be captured to stop the infection, whether it's the hashes or the storage. This video is going to be a bit long and few technical and good technical video where we are going to see how Medusa ransomware got built up and how it has spread across the world, and and actually given eye opening to everyone that whichever EDRs you install or XDRs you take in, or whichever security protections and mechanisms you build in, we are going to breach each and every security protection in the world. So Medusa is like an eye opening, like the one and the very old. But Medusa recently has given an eye opening to all the security solutions in the entire. So we are going to look into this, like how Medusa got spread out, what are we built for the Medusas, and what we can which can be which can actually save the not like and just to create every single code, every single API call, every single DLL that we are discussing with you to the point analysis. It is not like the nobody will point but we will talk about it completely in depth. So let's start. So I have the Medusa downloaded with me. That is Medusa.exe. You can get it from Malware if you want to. You can download it. There are a bunch of tabs. You can just go to Malware, write over the tag and Medusa, you will get a lot of EXEs. So if you want to see the type of file Medusa, you can get easily, like this is P32 table Intel 80386, and this is for MS Windows, and it has 5 sections in the PA header. Okay, so how the pro ransomware analysts they start working out. So there are two ways. Either we can start for the dynamic analysis, which generally a lot of people does, but this is how me and my team do. We start with the study analysis. We first try to identify spread. We can how the spread will be, how much the infection will be, and what will be the condition. So we actually start with the static analysis of it. And in static analysis, we generally go with analyzing the executable, that how this executable is actually working. So the very first thing that in every malware analysis or every malware analysis, what we start is to identify the hash of it. So for an example, if I want to know the hash of this particular file, I will simply run fd5sum Medusa.exe, and I'll get that. If I want, let me check if SHA-512 we can do, SHA-56 we can do, SHA-1 sum if we want to calculate, we can get SHA-1 value as well, and this is the SHA-value. So for an example now, if your organization has been hit with the Medusa and somebody has already clicked onto it, the very first hash that you can extract out from this is your this hash, and immediately you can put it in your EDR and scan the entire network, and you can get it removed. So within a few minutes, your EXEs will be removed. But there is something more to it. Okay, this is like, for example, what if this Medusa.exe got melted? So if I run this, there are some droppers in the machine. It drops, and this Medusa.exe got melted, like it is vanished, it is removed. So we need to go to the process level at that time. We need to see the threads, the DLLs it is connected to, what all the Windows native API calls that are being made. So we actually look to all those things. So we can start with something very interesting, that is analyzing the strings. So if I say sudo strings Medusa.exe, and we can start looking to those, start looking to the strings. The very first string is this prevent any term endorsement, means here on a correct side. It has a rich format. It has our data, or text, which is the nothing but a PE format, portable executable format. Let's look at something that we get it as an interesting. Now, when I was analyzing it, it actually took a lot of time to analyze it. So, and during the executions, we going through a lot of strings is something that is going to take a lot of time. So what in the team we do is we give one task to somebody and another task to somebody. So if we did identify certain interesting strings, let me just show this to you. Okay, so before that, you always remember that there are some machine compiled strings and there are some user compiled strings. You should, as the value analyst, you should always know that what are the machine compiled strings and what are the user defined strings. Always remember that. Only then you will be able to solve that which string I have to focus on. So let me check some custom strings here. Now function, and then memory, store. If happens is used, but it is some object value is FindFirstFileExW. And the file is asking that this file not in this file not belong, no such device, no such thing. Okay, this is something interesting, because no such file, no such device, not a failed, not a corrected, patient cancelled, progress, permission denied. So this is trying to access certain files and folders which normal users don't know. So it is giving the attack some signals. So we can see that. So there's also for some network connectivities too. We'll come to each and everything. But first let's identify something interesting. Too many files open on system. Okay, this is the footage on the read-only file system. Okay. Something interesting, which is your file ammo. Then it is asking for your free value, it is asking for your get value, and then it is asking for the set value. It is asking for initial critical system extended, init once, execute once, create event extended right, create semaphore right. So these are all Windows functions. It means it is trying to access, I think, NTV level. Select CreateThread tool, Go to set pool, wait for set pool timer callbacks, flush process callbacks, create symbolic link, right? Get current process number, get current process ID, get tick count. This is interesting. Where it is also have a tick count. Get system time to file, it is also processing time. It is file information, what type of file it is handling, sleep condition variable. This is interesting. Take on all condition variables. Of course, every module will have it. This is private file, the SOW log, exclusive, create thread to work, sleep condition, into a string, get local info. Something interesting. Okay, here is your PE events. Let's see, log already taken. It means something new text is being overlaid. I think this is your what we call it as the new text that is there. If I'll give correct wording into this, yep. Okay, so this is your named mutex, and if you know that mutex is nothing but your mutual extension. So mutex is like, before going forward, mutex is like a lock, that ensures that only one thread or process, can access resource. Example, something like a file or a memory or a device at a time. It helps to prevent the confliction or the corruption that can occur, when multiple threads or processes try to execute the same thing simultaneously. So that is why mutex was designed, so that every program is not resource at one time. So if I have to understand why mutexes are very important, it actually helps us to identify malware updates. It helps us to identify it helps us provides us the attributes about certain threat actors. So let's understand further. That's what we So we can see there's some set input and we have it's asking for the information. It is asking for the current process information, logical processor information, and it is giving account, rescheduler, version, event object. It is asking for processor roots. Interesting. Then certain things which every exe will do that. It is registering the trace GUIDs. Okay. And trace events, trace logger, CreateProcessS, etc. And then we have access violation to RTTI data. Okay. Vector deleting destructor. Okay. Something interesting. Okay. This is fine. This is interesting. App policy get process termination method. And app policy get thread initialization type. Then we have certain file errors. This is purely, I think, written in VB.NET, I think. Yep, here is something interesting. This is what we call it as path DB, program DB, which is let's talk about this very interesting. PDB is very important. It's known as a program database. So this is used, as a path to identify the location of the PD store. So, and it generally comes with your PDB extension. So what it does is it helps to identify the username, okay, the directory structure, the location, the malware variants, project types, and so on. So now we know that this project, when the user might be compiling or the attacker might be compiling this project, it was located in its G drive under the path Medusa releases and gaze.pdb. So this is our first IOC. Remember that. This is very, very critical. Once this is being fed into your EDR or XDR machine or in your security solution, nowadays firewalls also, nowadays firewalls also are scanning the application level things. So whenever this is being fed into your security solution, this will start getting blocked. Here is your memory allocations. Heap free, heap alloc, GetProcessA, set handle information, and here is something important, very, very important. It is asking for the drive information where it wants to write right? Then it is consuming your user32.dll, and here are your encrypting functions. So it means this is using bcrypt.dll, which means it is using the latest encryption standards to encrypt the data, and here it is also using the crypt32.dll. I think it is using the old digital signing certificates or something, to bypass the local antivirus or EDR machines. So this is very, very critical. Remember that always to look for such things in the static analysis. Then it is asking for local. This malware is very, very interesting. It has everything that a malware analyst want to practice. So here are very interesting things where we have the traits, like what exactly this malware might be looking in. You can pause the video and look in, or when you are analyzing it, you can look to it. But here is something that I want to show you is this critical information, which is your it is passing in as an XML value inside the Microsoft native DLL API calls that whenever this particular EX is being called, it will invoke without even the administrative request, without even the administrative request. So whichever files and folders this particular exe is able to access, just invoke and try to access those only. So try to escalate the privileges of the file. So this is very, very critical. This is your super IOC. Remember that. Let's go down to something more interesting. Okay, something interesting we have not identified more. Let's just go one shot. Here, I think we missed this. Here is your function execution. So it is asking for from here. Let's go up a little bit. So here it is initializing the function, and it is bypassing the function execution policy, and it will run the function with the predefined variables and then the command and the possibilities. So it means it is storing something inside its solution possibilities, and then it will start executing. It will load the key, it will provide the error. If it is not working, then it will execute the percentage s.exe, very very critical IOC. Remember that, then it will run a ping or the certain thing which it might be trying to access. So this is your another IOC. Okay. Okay, here it is checking for if file is already logged or not. Means whatever the file extension it might be using. I think it uses the Medusa as the file extension while inputting. Let's see if we are not missed anything else. Policy termination method, very important. Okay, I think we are good for our text. So for the strings, I was able to know that something interesting we have identified from the strings and multiple IOCs. So we went ahead and we loaded our this thing, detected easy, and we started using this detected easy. Let's go to the very first thing to understand. I hope this is visible to you, that this file is your Medusa.exe. Size of the file is this. This file is your 32-bit, and it runs with a string value. A string value is given as 386. Fine. Open the string Windows Vista. I have no why. Comes with the signature. Maybe I have no idea why. And it is running on architecture on i86. But I will show you that these are just the info based on your 32-bit module, but it is clearly running on 64-bit. I ran it like multiple times when I was doing the final analysis on this. Now, if you clearly see this, this is your header, which clearly shows you this that this is the MG, and it starts with the 90, and then we have one of null values over it. It means this is basically written for your rich format, and this is the entry point for this for the rich function, which it is entering into the memory at this point. It is written in C++. Here is the rich format, remember that, and we have the reading file link as the RSPS. This is very very important information to understand how this which language and which compilers were being used, while writing this particular website here. Even if you want to look to certain information about different tools, the first thing about detecting is this. You could see it time, but if you want to see this, it is only different information, compiler, you can see functions, systems, you can just do each and every one without the other. You can start reading about it and move ahead towards saying I didn't find anything interesting apart from the way this code was being compiled and is being written and others, because I am much more interested in the disassembly of it. Okay. And if you want to look to the Yara numbers, you can look to the Yara numbers. Here I did find something interesting. Here this is your ADV API 32.dll that it is using. So if you know that what TD is going to use, it is for your registry interaction. It is able to access your Windows services, security, and some crypto APIs. So it means this is, of course, we have already seen your bcrypt and all it is using. Then it is looking for crypt32 to find this function, and it is looking for your crypt32 DLL, which is saw in the strings as well. Then it is using CRC32 as a polyformic encryption standard. Then CRC16. Then it is looking for the your utils function, your utils library to get the flyutils.cmds function to use the ECB function, encrypt the ECB function. Then so we'll see under what it is being. Okay, under Yara, I think this was fine. Rest of the Yara rules you can build it over here, but I don't think that something interesting is here. Let's look at virus total. Virus total, almost all antiviruses have detected it recently. If you can see, recently all ransomware, this has been detected under Medusa. So we know that most of the antiviruses are detecting it under Medusa. So visualization, if you want to see, we see a lot of distortions, packers. You can see a lot of distortions here, and a lot of packers are being used under multiple sections, which we will see in some time. This is the hex value. This is the hex code with 45A, which is the value for your MC. Then we have null value, 90. Then we have no operations, and so on. Null values for no operations. Let's look at the hex code if something interesting we identify. Let's use the data inspector. Something. Okay, some event objects, virtual entries, disaster, okay, so we will get reasonable flags. Let's go a little bit down. So this is the theme that we have everything in the strings. The only thing here that is coming as object length, clock length, this, and then we have stream, bad iOS, bad streams. Let's see if we get here it is, your SHA-256, SHA-1. If you look to this, SHA-1, these are your hex bits for SHA-1, and these are your hex bits for SHA-256. So now we know something here. Then it is looking for some file names, Windows old, it is going to Windows old directory, reflogs, mcache, programs, file 86, program 86, program data. It started looking. So here is your ransomware execution, just skip, and your Windows old, perfect logs, kill. Oh, this is interesting. where it is killing some services and processes. It means when it runs, the Medusa ransomware, it is killing all the processes and killing all the services, and here you go. It is even deleting the shadow copies, and now it is encrypting the system. But how it is deleting the shadow copies? There is something there. There must be something as VSS admin somewhere. PowerShell execution. Delete. Let me just search for VSS. Okay, nothing found. Let's look in the strings. Search. Oops. Let me search for shadow. Yeah. Delete shadow copy. Again, so let's look to this sample code. Before I go to that, let's look to the hashes, which we have to look. These are the important hashes that are there for all your functions. This is welcome to the text, our data. Let's okay, we need to see if we can get it. Here is your memory mapping. If you want to see more, you can see everything over here. I will go there. And this is my something interesting topic. So see that if I'll particularly see the text option, this looks very, very distorted. It means something is encrypted over here, or it is being packed with some UPX or something as a packet. And if I'll see something on the relog side over here, so you see the pattern here, it goes here and then goes fine, and here is your some entropy level going up. So it means here is something and here is something going on. And if you see extractor, we have gzip. Let's use both the things, and we can see it is using a gzip. We can even dump the DOS tip if you want. I have already dumped it. If you want to, we will analyze it. Is it somewhere now? Okay, and this is our DOS code. If you look into this is very fast. This is my information. And we can for investigation files. Here is your FindFirstFile, and here is your logs and your debug information. This is your IOC that it is using this particular file, so deployment database, and then we have the functions that are being used here. Anyway, so let's look at if we can get something from this. Flaws also provides interesting strengths. So let it run for some time and then we'll see. So now it is extracting all the functions and features from it. Let it do that. So let's look at the flaws. Since let me just take on the. I have already submit the. I have already dumped the Medios. This thing. So this we have already seen. And they put like the loss is really good in this. So let's go with the start. This are already see static string this language identified nothing. Stack string and decode is 51. Very interesting. Very interesting. Those decoded strings. Decoded strings are generally at the last. So you can directly go to the last and look what it has decoded. Okay. Here you go. This is what we were looking for. So flaws is very critical when it comes to identifying certain strings. Flaws gives us very important information, So we have seen that it is deleting the shadow copies, but how? So this is the command. So it silently is deleting all the shadow copies that are there in the system. And these are the stack strings. Don't have to worry much. I think here is your encrypting everything. And it is going to each and every directory, every place, choosing the languages, it is using your Windows native calls. Another DL which is MSCall.dll. Interesting. And if you see the header file from the compiler, and here are certain Windows DLLs, so it is using Combase and ADB API 32 DLL along with kernel 32. Kernel 32. Okay, let's look at something which let me check it. So there is another. Okay, so there is very good tool which is kappa.exe. Now kappa.exe is very much informative when it is identifying something very critical. Let's look at the Let's run the Kappa, and you can download it from internet. So I have already downloaded it finally. I've compiled it finally, and it is working fine. So you can download it and compile it, and you can use it in your applications. So I'll run Kappa against Medusa.exe, and it actually has provided a lot of critical information when we were analyzing the Medusa. So let's look at it. And here we go. So this kappa is very important when it comes to analysis. So we use, when we are doing the static analysis, we generally use kappa as the static analysis. So it automatically provides the hashes which is there, and it is in the format PE and the architecture IPv6. Then what are the defense evasions? We will look at it sometime. The functions which are being used for defense evasions. We have state, file and directory permissions modification, IDAR effects, obfuscated files for information, obfuscated files and information related from under tools. Then it is also using certain functions to detect the virtualization and sandbox evasion. For discovery, it is using certain functions for discovery. It is just looking for the location, just looking for some shared modules, and gather with their information. Now you can actually look to these MITRE TTP values, and you can actually get information. But I will not get into this because I will show you in very depth these things. Then we have virtual machine detection, anti-behavioral activities under this objective, executable code obfuscation, inter-process communication, very important. It is creating the named pipes. It is encoding the data with XOR. It is encrypting the data and decrypting the data. It is using the standard algorithm. It is getting the file attributes, identify CreateProcess, CreateThreads, and SetFilePointerEx local values. And it is giving the references as well, which comes very important when we are analyzing any malware. So you can look for the namespaces it is using. It is using under connection, stack strength, connection, create, basic default, encryption, PDB, other file systems, read file, write file, storages, create TLS and all this sort of stuff. Okay. So this is what is being identified and is being there. So we use we actually use the quick one scope as as the analyzer. Let me just for certain functions. So now I have modified the quick one scope a bit to understand to make it working against the Medusa malware. So if you're downloading quick one scope, you have to little bit of working here and there with quick one scope. It analyzes very perfectly, but certain things I have added more into this, to analyze it in much deeper. I will to analyze it in much depth. So let me just look through Medusa. And then first thing is the virus total query. Okay. Very much correct. It is under the Medusa. So almost all antiviruses are detected it. Next thing we look for the packer. So it has identified the rich signature, the rich format, and it has given the offset for the that it is compiled under the Visual Code, and it has given the language as well and its offset values, and it is being written in the Visual C code. So far so good. Let's look for signature. The only thing that we don't know is this is the Windows portable file. Let's look for C# and C. And these are not 100% correct, so these are just the maximum possible patterns that we detect from the environment. Let's look at the MITRE framework, the MITRE TTP values, if something comes up. Okay, so it has given the access token manipulation, event triggered execution, and time-based evasion. Let's look something more interesting now. So let's analyze this. So it will take 2 to 3 minutes to do the static analysis. Let's look at it. So let's give it some time, then it's completely abstracted everything. This is a huge ransomware, so it will also take its bit of time to its generate to check for everything. Okay, so it has finally extracted everything. Now, if we will go up to learn about each and everything, but before going up, let's look out to everything. So it has the import export functions 367, categorize imports at 336, file strings 52, network strings 19, process strings 68, which is very high and very interesting. Menu manager 35, resource admin, daily admin 21. Here is something shocking, which is evasion bypassing 39, system processes 2, cryptographic functions 12, information gathering 6, 66, other and unknown 22. So if we go to the start from so we start from the these are the stream of functions which are introduced, which is file, file create, check file create, file, search file performance, these are the other functions. Name the pipe and processes functions. It is creating a process or name the pipe. This is close it the handle, just creating a process. Single project, single object, standard, switch to code, and the section. Then we have exit process, create process, and so on. And here is the memory based functions, which is of course the file is fitting. Then also for our log of the process heap and allow the heap token to virtual log and also the heap. Then this is the function for the other handling, and this is very critical. These are for all functions are being used for your creation details and identify set third party, persistence, set third party, and this also. Then we have the cryptographic functions, and they need to go to the phone. Verifies it is zero and then itself. These are also signatures for the keys to be. This is the custom factor which is called out for the escalation, which is supposed to be this. Then we have into the world, into the process is something actually example 6. Even if some population question, but still is okay. This is interesting. And then these are your strings only. I've already seen them. And there is a different options. And here is your parsing functions information. Very, very critical and very, very warnings. So we can dump this into the bin and we can extract it and run it. So what I have done, I have already did the analysis completely on this. Let me just get the file. So if you are able to see this, this is a Medusa malware ransomware. The file operation that is performing, ReadFile, WriteFile. It is asking for the GetFileAttributes, SetFileAttributes, MoveFile, FindFile, SetEndOfFile. Then for the thread potential, the next filtration it is doing, file encryption, self-modifying capabilities that we have already seen. Then it is using the networking functions, socket, find, then single object, interpreting a section. Then we allow to see the data. Then virtual allow purpose of virtual E, then the process. Then the function which is for the functions and small processor, encrypt socket, virtual allow, and under the condition this. Okay. Then also I have written a small query when we have to run it in the sim. How we will identify that here process name is cmd.exe and command line is admin delete shadows all point, medusa.exe and gaze.exe is the public present, encrypt, and what is the time and the process name and process ID for this. So this is something that we have written for our organization. You can also modify and use it based on your thing. Now what we will do is we will do a small dynamic analysis to identify what if all the static analysis is making sense, that this is how the ransomware is actually working. Let me make sure that my antivirus is switched off because we have already updated everything and it's fine now. So when we first shut down everything, let me remove it, disconnect, and everything's fine now. Let's just okay. Process monitor on. Let me put a filter on because I already know the process name as Medusa. So fine. We'll click OK. Then we should now run my sandbox. So the same modifications I have done here in the Windows script as well for Python. Scope is very good. I recommend everyone to use it. So let's run Medusa Ransomware. Actually, I will not run it from here. I will try it with the So it's going to be this over here. And this over here. Oh, this actually look for the process. It is killing all the antivirus services. Let's see what it is killing all the services. Let it run for some time. So it is killing all access services. Okay, let's check if the bin file is getting open. Yes. And it is also using net.exe with corpus. And okay, it is right now extracting. It uses two values this. Just creating the DLL files, querying which directory it is running from, is loading the kernel that it is DLL. You have cryptographic functions, which is just how the cryptography. And it is now it is started. See this. So let's see, this is running under now which process. And just no, it is. And it is using the and you see this. So actually we can create file, we need to merge it. The writers are seriously very risky, guys, and it has encrypted everything. Let it eat. You can see that all my C programs it is eating. And if let's go to here in the Python directory. Till where it has reached. Library site packages. It has reached to the site packages. Okay. Site packages, book interpretation. I think it is targeting the let it run. So it means it is running in the user mode itself. It means the manifest file we have extracted, it is working very correctly. Let it run. And here we can see Medusa encrypted. Let's look at the message that it has given. Let's close this out because we already know that this is running. So let's look to this. Let's see if it is running in the background as well. If the close call is removed, a lot of processes are running at the backend. And here we go. Registry close key, close file, Okay, fine, I think it has stopped. Let's open Medusa.txt. What it has given as a message. I don't know why it is not okay. So let's get it. We are the best ransomware group. Please call your Lano software you're running high value business. Here is their Telegram channel, we already know. Here is the Onion sites. I tried it, but I was not able to access it. I even using the Tor browser to connect to the chat, but the shut down. Okay, and this is your company identification hash. So I tried to connect it over here, but I was not. But something interesting which I have identified is the bin that is being created by this. So I started working on the bin files. You will see these are your bin files. If you get started, you will get a lot of good information. So I have already copied it here because I have run it multiple times. So they know. They already know the bin files. The extension to run the bin file, get -f. So I'll use the auto function over here. I'll use 0.36. So this has a Okay. So when I was analyzing the bin file, I found a lot of interesting things that was going inside my particular processes. So when you are running the transcript, that is the dump of the data which is going at the backend, which is in the form of this. So make sure that you block these hashes as well and immediately understand what are the IOCs. I hope you have liked the analysis, and I will upload the same on my GitHub as well, all the analysis and everything along with the IOCs. I hope you have enjoyed the video. We have blocked these IOCs on the pulses being created, and we have added the IOCs in that pulse only at Alien World as well. So do check it out. It is with some other name, but you will get it under the tag Medusa. So make sure that you analyze such ransomwares and malwares and keep the world safe. This is the only benefit. This will took a lot of time to analyze, identify the unknown codes and everything. So that is why I thought let's present it in the next video. I hope you enjoyed it. Stay safe. Stay away from the ransomwares. Think before you click. Thank you.